A student's knowledge of directly proportional and inversely proportional relationships is something that is routinely tested on the ACT Math exam. So what we'll do is we'll review what it means to be directly proportional and inversely proportional, and we'll do a couple sample problems. So when we have two variables that are directly proportional, so let's say a variable y varies directly with a variable x, it can be represented by the equation y equals some constant k times x. So let's do a problem. The table to the left gives experimental data for two variables. After analyzing the results of the experiment, it was determined that variable y varies directly with variable x. Which of the following values should be used as the constant of variation? So we're told y varies directly with x, so we can use that standard equation y equals kx. And we're asked to find the constant of variation. So we're going to solve for k by dividing both sides by x. And we'll get k is equal to y over x. We can use that to figure out what the constant of variation should be by testing a couple of data points. What we want to be sure of is that we test several data points because we're given experimental data, and experimental data is never perfect. So let's take the first point there, 4.51 divided by 1.2. That gives us about 3.76. Our answer choices have B at 3.69 and C at 3.31. Those are both fairly close to each other, so let's test a couple of other data points just to be sure which one we're going to get. So let's test the second data point, 13.07 for y divided by 3.6 for x. That gives us 3.6. Let's test one more to be sure, because the first two data points, if we average them, are a lot closer to 3.69 than 3.31. So let's take 17.39 divided by 4.7. And that gives us about 3.7. So we're going to go with answer choice B. All right, what about inversely proportional relationships? So if we're told that a variable y is inversely proportional to a variable x, that can be represented by the equation y equals k over x. So for our problem, we have two numbers, a and b, that are inversely proportional. When a is equal to 10, b is equal to 20. What is a when b equals 8? So we have our equation. We have a is inversely proportional to b. So a is equal to some constant k divided by b. We're given a value of a and a value of b. What we don't have is k. So let's solve for k. So we can rewrite this as a times b is equal to k, and then we can insert our values. So we have 10 times 20. And that's going to equal 200. So we have k is equal to 200. So now we need to figure out what a is when b equals 8. So now let's just solve for a. So a is equal to 200, the constant we just calculated, divided by 8. And that leaves us with 25. For our last example, it takes 5 people 6 minutes to fully assemble a widget. How long will it take 2 people to fully assemble 4 widgets? So these problems, at first glance, may not look like they are problems about inversely proportional relationships. However, if you ever get something written in a similar format, such as people painting rooms or some other thing like that, then you can rest assured that this is an inversely proportional relationship. So let's define some variables. So let's say we have n represents the number of people. We have t is equal to time, and we'll have k represent the rate constant. So now we can say that time and the number of people are inversely proportional. So time is equal to k over n. again, like the last problem, we're given two values. So we're actually given t, which is 6 minutes, and we are given n, which is the number of people at 5. So let's solve for k. So k is going to be equal to n times t. So k is equal to 5 times 6, or 30. Now that we have that constant, we can actually solve the second part of the problem. So how long will it take 2 people to fully assemble 4 widgets? So let's solve for 1 widget. Let's do 1 widget. And we are given time. That's what we want to figure out. We know that the constant k is 30, and then we know the number of people is 2. So it should take 2 people 15 minutes to assemble 1 widget. So for 4 widgets, we'll take 15 times 4. And that's going to give us 60 minutes, or 1 hour.